All right, here is 1-5. Just one day on it. Topic is complex numbers. We don't go crazy with them. But when you're working with polynomials, they can, complex solutions to equations can come up, okay? That they kind of are necessary if we run into the square root of a negative, okay? So far, we have learned that some quadratic equations have you could call it complex or imaginary solutions. For example, if we were to solve x squared plus 1, we'd subtract 1 from both sides and get to this, x squared equals -1. The solution would be the square root of -1, which on the real number line, you would not find a number. Okay, when I say the real number line, that's just think of a number line, right? 0 in the middle, positives to the right, negatives to the left. You can't find a solution to this problem, right? So essentially what happened is mathematicians made up an imaginary unit, right? To just specifically to deal with this case. What do we call it? We have the imaginary unit known as I, which is just what we call the square root of -1. Okay, that's a better way to think about it. Like, oh, it's the answer, right? To the square root of -1, which is a little bit weird. Where it's like, oh, to get an answer, we just made something up. Kind of. Again, it's just what we're calling it. I is the square root of -1. Now, keep in mind, right, if I write out down here, I times I, which would be I squared, would be the square root of -1 times the square root of -1, which would be just -1. Okay, you'll see that come up a little bit when you're working with complex operations, which that's really basically all we're going to do here in 1.5 is some of the basic operations that go with complex numbers. We're not going to really get super deep into them. If you're dealing with equations that have exponents, like 2 or 4, like an even exponent, i's can show up, and so we'll go over some of the basic cases where they do. All right, these imaginary units, along with the real numbers, make up what's called the complex number system. You are used to seeing this, right? 0, all the positives, right? All the negatives. That's the real number line. Okay, now up until functions and even within functions, 99.9% of the math that we do takes place on the real number line. Okay? There is a vertical axis as well that has the imaginaries, which its scale is 1i, 2i, 3i, 4i, and so on. Okay? So if you were to, have a number like right here, we'd say a plus bi, that technically every number has both components, okay? The first one, a, we'd say is its real component, and that's all you would see if the imaginary component, or b, is 0. And again, for us, that's almost all the time, right? We really don't get into a lot of situations where you would need to go on the imaginary number line, okay? So if b were 0, then that b times I just wouldn't show up, okay? but it's technically there. Again, if it's a real number, b is 0, okay? So you should get used to seeing complex numbers in that form. The two parts, the real and then the imaginary. All right, really the next few slides, we'll just do some of the basics of how you simplify expressions that would have imaginary answers and do some operations. All right, if you had something like this, what is the square root of negative 25? Okay, typically split it up, right? Get the negative sign out of there. So I would just go square root -1, square root 25, and then it becomes two components, each of which we know the answer. The square root of -1 is I. The square root of 25 is 5. Now, typically speaking, we would switch that order, right, and call that number 5i. All right, over in part B, nothing to do with -5. Square root -9, I would do the exact same thing. Split it up, square root 1, square root 9. Square root -1 is I, square root 9 is 3. Right, and here we see a complex number that has both parts, right? Its real component is -5. Its imaginary component is 3, okay? What you saw over here on 5i, that's basically one where a is 0. Right? It's just straight up an imaginary number because its real component is 0, okay? All right, moving on. Moving on. All right, I'll try to keep each of these kind of narrow and vertical so we can have room for all of them. Okay. All right, if you are adding or subtracting, think of it like combined like terms. Really all you're going to have is two of them. You have the real and the imaginary, okay? Imaginary terms can get combined. Real terms can get combined as well, okay? On the first one, I can basically drop the parentheses, right, because there's nothing to distribute. 4 plus 1 is 5. 7i minus 6i is just 1i, okay? Really same thing here, okay? 1 plus 3 is 4. 2 minus 2 would be plus 0i. With no imaginary component, that would just be 4, okay? You should typically get either a real number or imaginary number or something that's in the form of a plus bi. Okay, you should only have, two terms at most, the real and the imaginary. All right, over here we've got some distributing to do. I've got 3i, but I distribute the negative and it's plus 2. And then minus 3i, minus 2, minus 5i. All right, first thing I notice is the real components. I combine those and I don't have any. And it actually looks like the 3i and minus 3i. Those will cancel, right? Now there, instead of two numbers, I just got 1 because this did not have a real component, right? We had, in the step before, 2 minus 2 that just canceled each other and were 0. All right, same thing over here. Nothing to do with 3 plus 2i. Nothing to do with 4 minus I. Here I got to distribute the negative sign. Minus 7 minus I. Once those parentheses are all gone, just a big thing of combining like terms. That's all it is. Okay. Now this one gets a little interesting too. I got 2i minus I minus I. That's basically 2 minus 2. And then there's 7 minus 7. That whole thing simplifies to 0. Okay. Again, this was adding and subtracting with complex numbers, okay? Again, if you just think of the two parts, real and imaginary, distribute to get rid of your parentheses, and then it's just a bunch of combining like terms. All right, last two topics. We'll be multiplying and dividing. This slide will just be multiplying. Typically speaking, think of it like a foil, and then keep in mind, if you ever get an I squared, that's the same thing as -1. This one I don't have to think about it as a foil, but it's just like distributing, okay? Which will give me -8 plus 12i. And again, that's the form I'm looking for. It's got a real component of -8. It's got an imaginary component of 12. This next one looks a little bit more like a foil. So we have 2 times 4 is 8. Plus 6i minus 4i minus 3i squared. That looks like a little bit of a mess. But the first term, we just have 8. 6i minus 4i is 2i. And here's where I need to use the fact that I squared, which I shouldn't leave, because again, when I'm done simplifying this, I should have 2 terms, one with an I and one that's just a number, just a real number. Okay? So I can't leave the I squared, but I use the fact that I squared is -1, and that becomes plus 3. And there I get down to just 11 plus 2i. All right, next one. This is kind of a particular little example that's kind of significant. It'll really come up when we start dividing complex numbers. These two numbers are called conjugates. Notice they're basically the same complex number, but the sign in between is different. I want to show you what happens here if you multiply conjugates. We treat it like a foil. So first, outer, inner, and last. Those cancel. I squared is -1, and this basically becomes 9 plus 4, which is 13. Okay, you're going to notice that happen every single time when you multiply conjugates. Their product is always a real number. Okay, so again, that's the same complex number, but you just switch the sign in between. You're going to see here that's not going to happen because this number I'm going to multiply by itself. So the sign in between isn't different, so I'm not going to have this canceling effect that I had in here. I'll get 9 plus 6i plus 6i plus 4i squared, or 9 plus 12i. Get that -1 in for I squared. That would be like 9 minus 4, get 5 plus 12i, okay? And again, it's always worth a reminder here that I should be getting to that a plus bi form, right? The only exceptions would be if I get a number that is real and doesn't have an imaginary component, or a number that's just imaginary, right? Like 4i or 5i or something like that. All right, last slide here. All right, oops. So we're kind of following up on the same same topic here with the complex conjugate. Which there it kind of states it formally that if it's a plus bi, its conjugate is a minus bi, right? Literally just change the sign in the middle. It's really useful if you do it when you're dividing complex numbers, because you don't want the complex number in the denominator. And that's what this will do, is it'll ensure you that you don't have a complex number down in the denominator. Okay, now the first one's a little bit different right here, 4 over I. I want you to see that one because it's just the imaginary component. If that's the case, just multiply by I over I, okay? Because then what you'll find on the top, you get 4i, and on the bottom you'll get I squared, which is fine. Because you'll have 4i over negative 1, which would be negative 4i, right? So that took care of the issue, right? But basically, if I'm dividing complex numbers or imaginary numbers, I just don't want i's on the bottom. That's all I'm really after. So in part B, you have more of this typical case, okay? And you'll notice here that multiplying by I over I won't do it. You got to go 4 plus 2i times 4 plus 2i, okay? That is the one that you're looking for. So it becomes kind of like a super foil, if you will. Because I got to foil the top and I got to foil the bottom. All right, so on top you'd have 4 times 2, which would be 8, plus 4i. Plus 12i. Whoops. Plus 6i squared. Right? Obviously, there's going to be some cleanup to do on top. Right? Got some like terms to combine in the middle. I squared, I can put in negative 1. We'll get there in a minute. Okay? All right, 4 down the bottom, right? Now this is where we're multiplying the two numbers that are complex conjugates, right? We saw this on the slide before that if I do this right, I should get a real number on the bottom, okay? Something like, I don't know exactly what it's going to be, but 12 or 13, right? No i's. 4 times 4 is 16 plus 8i minus 8i minus 4i squared. Okay. Now I'll get to the top here. We'll have 8 plus 16i plus 6 times negative 1. So that's going to be like a minus 6 at the end. Here, there, your middle terms cancel. I squared gets negative 1. So it looks like the bottom will be 20. Okay? Bottom will be 20. Now back up top, right, that really was minus 6. So we'd have 2 plus 16i. There's the real component of 1/10. Right, I'm trying to simplify my fractions here at the same time. This one I believe should be, both have a common factor of 4. Should be 4/5. I get some fractions in my answer, but, 1/10, that's the real part. 4/5, there's B with my imaginary part. Okay? All right, that's all. And really in this chapter, all that's left is to kind of work our way back to quadratics and to work on some applications.